This is one of a series of short videos showing how to do computational physics. In this video, we're going to introduce the use of scripts in MATLAB. As usual, we start with the MATLAB main window, the integrated development environment, and the command window that we've seen before. But instead of entering in commands at the command window, we're going to create a so-called script. Now, depending on the version of MATLAB that you have available, you can ask for a new script using one of the menu buttons which are available at the top of the screen. And these are different depending on which version of MATLAB you have. You can see here that I can create a new blank script by pressing this button. And on some versions you won't have this button, but you will be able to get a new script by clicking on the new button or the new menu item and choosing new script from the list of options that appears underneath. So we're going to create a new script, and when I do that, you can see that an editor window has been created. The file name is as yet untitled, and you can see that the command window has moved down towards the bottom of the screen but is still available. So let's highlight the editor and we'll start entering in some script code. Now, a script is basically the same thing as a program, in that I can enter in a series of commands which will be calculated sequentially, and I can save those commands into a file so that I can reuse those commands at a later time without having to enter them again, which of course is much more convenient and is the basis of programming. So I'm going to do that now. I'll enter in a few line spaces. And I do this because it allows me to move more freely up and down the editor window, and if you do this at the beginning of entering any script, you'll find that it will save you a little bit of annoyance at a later time. And as soon as I've done that, you will notice that a star appears at the top of the editor window and in this tab area here as well, and this indicates that the present version of the file that I'm working on hasn't yet been saved. So let's enter in some commands. I'm going to type a equals 2. So I'm going to define a variable a, which is equal to 2. I'm going to define a variable b equal to 3. I'm going to define a variable c equal to 4. And I'm going to define a variable d equals a plus b times c. I am now going to save that file, and on Windows that will be done using Control S, or on Macintosh by using the Command S, the little flower symbol, or of course I can do it using the Save menu item, and I can either save to the current file name. Of course, if it's as yet untitled, it will prompt me to save it as a particular file name that I have to choose, or I can save it to a new location. So I'm going to go back here. You will find that using the keyboard shortcuts will be much more convenient. So I use Command S on Mac or Control S on Windows, and I can choose a file name. I will choose my first script as my file name. And if I hit return to save the file, you will see that it appears in this left-hand window, which tells me what is the current folder that I am using. And this file appears here, and you can see where this current folder is. It is appearing, and you can see this file dialog displays the path to that folder. This is in my user directory, and again, different versions in different operating systems will by default put MATLAB scripts in different places. So I go to the editor window, and if I want to run this script, I simply press the run button up here. I click run, and this series of commands has now been run. So this is a computer program. And MATLAB, unlike some other computer programming languages, like for example C++ or Fortran, MATLAB is an interpreted language rather than a compiled language. So when the program is executed, the lines are interpreted and run immediately. And a script file appears with the commands are executed effectively within the command window, or which you might say is the global scope of MATLAB, so that if I run multiple scripts, if I had another script and I also ran it, then all those commands are run as if I had entered them in at the command window, with the caveat that there are some things I can do in a script which are rather difficult to do within a command window line. So let's open up the command window and we can see what's happened. So you can see that the command window has echoed each of those executed lines of code. It's defined A as 2, B as 3, C as 4, and D has been calculated and displays the answer 14. Now it's interesting to ask yourself how the operator precedence has been implemented when executing this expression, A plus B times C. But I hope that if you look at that code closely and think about the values 2, 3 and 4, you will see that B times C has been calculated first. It is the multiply operator has taken precedence, and A has then been added afterwards to the result of B times C. So this is done without the use of parentheses, without the use of brackets. And if I wish to have the calculation done differently, I can put brackets where I wish to have the precedence applied. So if I wish to have A plus B added together first before multiplying by C, then I can do that. And if I press run, of course, a different answer will come out. In this case, D is equal to 20. So that's just something to watch out for. Don't automatically assume that the calculation, these arithmetic operators, or even other forms of more complex functions, are being applied sequentially in any particular line of code. Now, when I execute the script, you will see that just as if those commands were executed in the command window, the workspace is now aware of these so-called global variables. They have all been defined and are now available within the entire workspace. So even though the program has finished running, I can now type A in the command window and I can see that A is defined. So when the script file has finished executing, all the values, all the variables which have been defined are now available back in the command window. Now, one thing which is a very useful shortcut, and this is very useful if I'm editing files, is if I happen to be in any of the other windows, for example, I'm in the editor window, if I hit Control 0 or Command 0, I can move the highlighted window, in other words, the window in which my cursor appears, into the command window. And this is very handy if I wish to switch quickly into the command window to either run the program or to check something. Now, another way of running this script is, rather than pressing the run button, I can also type my first script in the command window. Notice that I don't need to type the .m at the end of the file name. You can see up here that when I saved my first script, I didn't put a .m at the end of the file name, but MATLAB has put a .m, and this is an indicator that this is a so-called MATLAB script file or a .m file. So .m files, once you've installed MATLAB, that .m file becomes associated with MATLAB, and if you double-click on it, it should launch MATLAB and open up that file into the editor window. Now, just as a tip, it is possible to create and to edit script files in any other text editor. These script files are stored as simple text files using the formatting which is default in your particular operating system. However, when you create one of those script files in another editor, it is not automatically known about by MATLAB, and in particular, MATLAB may not know to go looking for that file when you try to execute it. However, if you create this script file within the MATLAB editor, then MATLAB should be aware of it, because it will save the file wherever you put the current folder, remembering that you can actually change where you save the file, and MATLAB should keep track, in most cases, of where you have saved that file, and then it will be available to run. So if I type my first script and hit return, you can see that just as before, it's run all those commands. Now, it can be a little bit inconvenient, as you can see, that when I run this script, a large number of lines of results have been displayed. And a nice thing that I can do with MATLAB is to suppress that to make sure that I only display the things that I want to display. So what I can do to do that is to put semicolons at the end of each and every line. So let's do that. So you can see that a star has appeared at the end of the file name to indicate that my file is now changed. I can hit Control S or Command S to save the file. Notice that the file has now been saved, and this other file here with a little tilde at the end of the file name this is a backup file. You can usually ignore that, but in case you were wondering what that was, that is a backup file. If I now go back to the command window by hitting Control 0 or Command 0, I can now press the up arrow key and I can replay the previous command. So I can play my first script, I can run that command, and now nothing appears. Great, so that's not very helpful, you might think, but what this means is I can now control exactly what I want to display, and this is highly recommended in MATLAB. Rather than just omitting one of the semicolons when you want to display the result of a calculation, it is actually better practice to explicitly display the things that you want to display. So how can we display the results of a calculation? Well, perhaps there's a command called display. We'll type help display. Is there a display command? Well, there does seem to be. What does it say? It's not display. It is, let's say display, or it also can be written as disp. So actually we're going to use the function disp, which is the more common one to use, which is display array. So display array will also work on single values, so let's use that. And disp is used quite a lot as a quick way of getting something displayed on the screen. There are more sophisticated ways of doing things that we will see later on. But let's display the result of our calculation. We'll do disp D, and we will put a semicolon on to show that it does actually display something on the screen. And we'll do Command S to save the script, because that's good practice. And this time I'll press the Run button, and you can see that the Run button has actually asked for my first script to be run, and the answer 20 has appeared, which has been the result of running this final line of the calculation. Now, we've created our first script, but it's not really very descriptive yet, and let's enter a little bit more code to make this code a little bit clearer for someone else to read. So what we're going to do is we're going to enter comments, and again it's highly recommended to enter in comments into your code so that people can understand what it is you're trying to do. Now of course this is a toy calculation, you might say, where these particular calculations are just being done as an example. So let's put that in. So I've put a few returns in to create a few line spaces, and I'm going to enter some comments, and I can enter comments using the % command. So the % command is, so the % character is the character used to indicate a line which is commented, which means that when MATLAB executes this file, it will ignore any characters which occur after that % sign. So I will write my first script, and you can see that MATLAB has highlighted that line in green to help you understand that that line won't be executed. And it's usually customary to say who you are when you write code. So I'll write this is my name and the date that I wrote it. What's the date today? 8th of January 2016, and so on. And another thing you can do to help your code to be a little clearer is you can enter some whatever characters you like. I'm just going to put some hyphens here, some dashes, which helps divide up the code and makes it a little easier to see. I can use the keyboard shortcuts to copy that line, and I can put it in here. So you can see now that with a few lines, what I can do is I'll just tidy that up a little bit, get rid of that one there, and I can say do some example calculations, and below here I can do display the result. And I save the file again. It's good to get into the habit of regularly hitting Command S or Control S to regularly save your file in case you do something bad that crashes MATLAB. It does happen a little bit more often than you might hope, and you can run again. And of course the answer is still the same. So that's our first script. Now this is not everything one should be aware of when writing a first script. As you can see, if I run a script and I generate some variables, these variables A, B, C and D, they will persist in the workspace even though the script has finished running. And if I were to run the script again, then those variables are still in the global scope, they're still in memory. And this is different from most programming languages, where when you run a compiled program, that program launches itself into a new area of memory where it doesn't know about any previously defined variables. So when I have an interpreted program within MATLAB, the fact that there are variables which persist from run to run can lead to some confusions. For example, if I happen to change a equals 2 and I do b equals 5, you can see that actually if I were to quit MATLAB and relaunch it so that all those variables in memory have disappeared, this program will no longer work, because when I relaunch MATLAB, it won't know what the letter A stands for in line 11. So I might do some programming, I might inadvertently delete line A and carry on writing some program code. I may think, I finished my code and everything's working. I close MATLAB down and I launch MATLAB the following day or the following session, and I try to run it again, and I get very confused because it doesn't work anymore. Let's test that and see that in action. I can simulate the effect of relaunching MATLAB, at least in the case of variables, by typing clear all. And clear all, you can see, deletes all the variables from memory. You can see on the right here that they've disappeared from the workspace. So if I now run my first script again, you can see that it doesn't work because it no longer knows about variable A. And just imagine if I had a number of different script files which might do similar calculations. For example, I might have a calculation that does one sort of integration, and then I do another one that does the same calculation but with another sort of integration. I may have quite similar code coexisting within the same environment. So I want to be able to trap that, and a good way to trap that is to get into the habit of typing clear all at the top of every script. So I type clear all, put a semicolon on there, and by doing this, what I do is I ensure that whenever I run this script, it starts afresh. It starts from scratch with a clear slate, and it defines all the variables that it needs, and that means that this script should be able to run when I quit MATLAB and run it again in another session. Just noticed here that I should have put a C there. So of course now what I want to do is I want to fix my code, so I put in A equals 3 again, put the semicolon on there and save it, and if I run it, you can see that it now runs. Of course I've just changed the calculation slightly so the answer is different, but you see the idea. So this means, so by having clear all at the top, it means that I can keep track of whether this program really does work in a standalone way and doesn't rely on me having had variables defined somewhere else other than in the script itself. So that's the basis of using MATLAB script files and the edit windows. In the next video I'll show you how to use more sophisticated things in a script file.